Once again, we come back to quadratics. Now we study the different algebraic forms of them and how to determine important graphical information from the equation. So far, we have seen quadratics only in this form here, where the quadratic of x equals ax squared plus bx plus c. We can use the technique called completion of the square that we studied in the last video to make this equation into what they call standard form, even though it's really not standard at all. Let's do that on this quadratic here, x squared plus or minus 6x plus 10. This is going to be a little bit different because here we do not have two sides to work with like we did with the circle. So it's going to be slightly different, but the process is nearly identical. We look at the x term by itself, take the number and divide it by the number 2. That gives us -3. And we take this number and square it. Gives us +9. This is what we're going to add and subtract now on right next to each other. This is the difference between circles and quadratics. Quadratics, we don't have two sides to work with. Circles we do. So we could just add them to both sides with the circle. In this case, to make sure we don't change the equation at all, we have to add and subtract it. Of course, +9 minus 9 is 0, and so it's like we're adding 0 to the equation. So it doesn't change the equation at all, but it does change the form of the equation, which is what we're looking for. You see how I've nestled in +9 minus 9 right into there. Always make sure you do plus and then minus. The plus is what combines with the rest of the quadratic and factors into the complete square. We're still going to be using this number to get x minus 3 squared. It's always the plus that does it, not the minus. The minus has to go with the rest of it. This thing now becomes x minus 3 squared, and then -9 plus 10 is +1. So this is what's called the standard form, or probably more accurately described as the vertex form of a quadratic. One of the most important points on the quadratic is the vertex, which is going to be either the minimum or the maximum, depending on if it's opened up or opened down. And this vertex is, the formula looks like this. F of x equals a times x minus h squared plus k. The vertex is at hk, and a here is a multiplier. It's what's making it open wider or be very thin. It's to just kind of change the shape of the quadratic a little bit. In our problem here, a equals 1, and the vertex is going to be at 3, 1. What does this look like? It looks like this. 1, 2, 3, 1. That's where the vertex is. If a is positive, it's going to open up. If a is negative, it's going to open down. I know a little bit more. You could, of course, plot some points in, but that's what it looks like as a rough estimate. If you wanted a good graph, well, just graph it on some graphing software. You'll see that in this case, since a is positive, we have it opened up, and the vertex, because a is positive, the vertex is a minimum. If a is negative, it's going to open downward like this, and the vertex here is going to be a maximum. So a tells you a lot about the shape of the graph, whether it opens up or open down, if it's wide or if it's thin, and the vertex is kind of like, it's like the center of a circle, but it's not a center, obviously. It's not a circle. It's a quadratic. And this shape, if you don't remember, is called a parabola. So what we want to do here is find the vertex of these quadratics. So for g of x, the first one here, the vertex is pretty easy to find. It's already in standard or vertex form. The vertex is going to be at hk, which is 1, -2. Again, the formula is ax minus h squared plus k. Since we have -1, that means h is positive, and we have -2, and that's supposed to be a positive k, so k has to be -2. For this next quadratic, we have to first move the 3 over by adding it to both sides. And we get y equals x plus 2 squared plus 3. Then the vertex is going to be at -2, 3. This is supposed to be x minus h, so for it to be x plus 2, h must be -2, negative to negative is positive, and then k has to be positive 3. For h of x here, we need to complete the square. So we look at this term, divided by 2, we get -1. -1 squared gives us 1. The 1 is what we're going to add and subtract, and this is going to end up giving us x minus 1 squared as a complete square. So we have x squared minus 2x. Here is where we're going to add 1, minus 1. We always add first, then subtract. And this is now a complete square. X minus 1 squared. -1 minus 15 is -16. So the vertex in this case is 1, -16. There is an easier way to find the vertex. Completion of a square is an important technique if you're going to go further into mathematics. There are some calculus problems that completion of a square really helps out with. But typically for this level of mathematics, completion of the square is a technique they teach you, but you don't really need to know, because you don't have to use completion of the square to find the vertex. In fact, there's a little bit of an easier technique. Actually, it's a lot easier of a technique. And it's using this formula here. The vertex of a quadratic is at -b over 2a, and then f of whatever that number that you just got it was. So in this case, -b over 2a, we think about this as ax squared plus bx plus c. -b is going to be negative of -7 over 2 times a. A is 2 in this case. And we get 7 over 4. So 7/4 is the x coordinate of the vertex. To find the y coordinate, all we have to do is plug in 7/4 into our function. 7/4 squared minus 7 times 7/4 minus 4. You get 49 over 16 squared minus 49 over 4 minus, we can do 16 over 4, but then we have 98 over, well, divided by 2 gives us 49 over 8 minus 49 over 4 minus 16 over 4. We need 8s in everything, so we can actually add them together. We get 49 over 8 minus 98 over 8 minus 32 over 8. And when you do this whole subtraction, we get -81 over 8. You can, of course, just use a calculator to find the number. It's probably going to give you a decimal, so you got to make sure you write it as a fraction, because that's how we're going to use the vertex, because the vertex is going to be at 7/4 -81/8. If we wanted to find the vertex using completion of the square, this would be a lot more involved. There's a lot of steps to it. It's very easy to get wrong because there's fractions. But what you'll find is, since a here is 2, what you'll find is if you did do the completion of the square, which I encourage you to try on your own, there are some extra steps you have to do. You have to take out the 2 and make sure you're adding and subtracting the right spots. But the vertex form of this is going to be x minus 7/4 squared minus 81/8. And that's all we did to find the vertex. We just found the vertex and then made it into vertex form, or standard form. Okay, to find the vertex here, we're just going to use the -b over 2a thing again. In this case, we have c plus bx plus a, right? It's not written in the standard, the highest power to lowest power. We can write it that way. It would be pretty easy to do. Like that. So now for our vertex, we have negative b over 2a. F, in this case, is going to be m of negative b over 2a. So negative b is negative negative 4 over 2 times negative 1 now is a. Gives us 4 over negative 2, which is negative 2. To find the y value of the coordinate for the vertex, we're just going to do m of negative 2, which is 5 times negative 4 times negative 2 minus negative 2 squared. 5 plus 8 minus 4 giving us 13 minus 4 is 9. Yeah. So our vertex for this quadratic is negative 2, 9. And I can actually write this in vertex form quite easily. A here is negative 1. So we have negative x plus 2 squared plus 9. This means that it's open down. It's going to look like this. And this quadrant point right here is going to be negative 2, 9 on the Cartesian coordinate system. In all of the quadratics, you will see a parabola that has symmetry. The line over which is symmetric is called the axis of symmetry. But notice for these parabolas, if I draw a straight line right down the center, if I could draw straight, this parabola is symmetric over that blue axis, and the other parabola is symmetric over this green axis. That's the axis of symmetry. This is always going to go straight through the vertex. The vertex is kind of the defining point between the two halves. And so if we can find the equation of this axis, which is a vertical line, so it's going to be x equal to something, what it's going to be equal to is the same thing as the coordinate, the x coordinate of the vertex. So for the green line here, we see that the x coordinate of the vertex in this case is going to be negative 2, negative 1. This axis of symmetry is going to be x equal to negative 2. For the blue line, the vertex of this parabola is at 4, 2. And the axis of symmetry is x equal to 4. That's the vertical line going through it. To find this, if you don't have a graph, you can just use the previous technique that we already talked about. The x coordinate of the vertex is negative b over 2a. So let's look at this function here. And let's find the axis of symmetry. So the vertex is going to be at negative b over 2a, and then f of negative b over 2a. So let's see, negative b is negative 8 over 2 times a here is 1. We have 8 over 2, which is going to be 4. Then f of 4 gives us 4 squared minus 8 times 4 plus 14. 4 squared is 16 minus 32 plus 14. That gives us negative 2, I believe. Yeah. The vertex for this thing is going to be at 4, negative 2, which means our axis of symmetry, we know, is going to be x equal to 4. It's always the same thing as the x coordinate of the vertex. To graph this quite simply, let's see, 4, negative 2. Just trying to make sure I know exactly where it's at. 1, 2, 3, 4, 1, 2. A in this case is A equal to 1, which means it's positive, so it's going to be opening upward. It's going to go like this, and looks like that. And you can see the axis of symmetry is at x equal to 4. So the domain of all quadratics, the domain of this is, it's always going to be negative infinity to infinity. That's because it's a polynomial, and polynomials always have everything in the domain. The range of all quadratics, this depends on the vertex, if it's opened up and opened down as well. In this case, we have an opened up quadratic, and the vertex is at 4, -2, which means if it's opened up, that means the vertex is a minimum. You can see that directly from the graph. This is a minimum point here. That means the range is going to start at the minimum, the y value. In this case, the y value is -2. So the range is going to start at -2 and go up to infinity. I actually need to draw a square bracket around the -2 because that point is included in the range. In fact, for all of the quadratics we've done, all you have to really do to find the vertex, or sorry, the domain and range, the domain's everything, always. And the range is going to be, if it's a minimum, you start there and go up to infinity. If it's a maximum, you go from -infinity up to that range point. So for instance, back here, these guys, for this one, the domain is always that. The range, you can see that this is a opened up parabola, which means this is a minimum point. And so we start at the, I keep putting parentheses around there, it's a square bracket and up to infinity. For this one, the domain is -infinity to infinity, as always. And the range, now the vertex is a maximum since a equals negative. In this case, a would equal -1. So we go from -infinity up to the y value of the vertex and including it. You see how it changes. If it's opened down, you're going to have -infinity to some number. If it's opened up, you're going to have some number to +infinity.